This is the video lesson for Mod 1 Lesson 2, Calculating and Verifying Inverses. In this lesson, the learning targets are going to be determining the inverse of a linear, radical, and quadratic function, and verifying a function is an inverse using y equals x. The first example we're going to look at is really just kind of noticing these two different functions here. So g of x and f of x. So g of x and f of x are actually going to be considered inverses of each other. And so there's a couple different ways that we could have identified it. So the first thing we're going to look at is, well, what do we notice about these two functions? In this case, they're both linear functions, right? They're both in the form of where they have a slope, they have a y-intercept, so they're both linear. They do intersect at a point. In this case, the point they intersect at is 6, 6. Where you can really see what graphically it means that for them to be an inverse is if you were to graph the line y equals x, right? And y equals x is a line with a slope of 1 and a y-intercept of 0. If we were to graph that line y equals x, we would actually see a little bit more of a relationship between these two lines. We can actually see that f of x, if I reflect f of x across that y equals x line, the red line I just drew, you're going to see they're actually symmetrical, right? So there's kind of a relationship we see with this idea of y equal x and being symmetrical. So graphically, an inverse, you're going to notice that they're symmetrical. So f of x and g of x are symmetrical about or reflect about y equals x. So if I reflect it across y equals x, I'm going to create the other function. In addition to noticing that they're going to be symmetrical, there's also something you're going to notice when you evaluate. So for example, if I was to take f of x and evaluate it at -4, and I can even read that off the graph if I want to, or I could substitute it in. At -4, that's this point right here, you're going to see my y value is going to be a +1. So it actually equals +1. And I could have substituted in that -4 in there and gotten that same answer. Same thing if I was to look at what g of 1 is. Well, g of 1 is this function right here. I could substitute it in. I could also read it off the graph. I see +1s here, so that's going to be -4. And that's the point 1, -4. Right? So what ends up happening is on f of x, I have the point -4, 1, and g of x is the point 1, -4. So it's not a coincidence that the x and y values are actually reversed, right? So the -4 is the x value in f of x, it's the y value here. That's not really a coincidence, right? So we're going to find with inverses, really, we're just undoing operations, and we're going to see kind of this idea of reversing or flipping x and y. For the last piece here, it says, well, if we find f of g of x and g of f of x. So if I was to take these two functions, and I'm going to start with the looking at the inside first. I got g of x. So if I was to write f of g of x, I can take f of x, that's the one on the outside, and in place of x, I'm going to write g of x. I'm going to write 2x minus 6. So when it says f of g of x, I'm really just taking g of x and plugging it or substituting it into f of x. So when I go ahead and simplify, 1/2 is really like dividing by 2. I get 2x, or divided by 2, minus 1/2 times 6 plus 3. And when we go ahead and simplify that out, we actually get x minus 3 plus 3, or we get x. So f of g of x is actually equal to x. Same thing if I was to do it the other way around. So if I was to do g of f of x, g of x is 2x minus 6. So 2, I'm going to leave a gap for that. And in place of x, I'm going to write 1/2 x plus 3. And then if I distribute, I get x plus 6 minus 6. And g of f of x is 6, right? And that's actually not a coincidence. Again, since these are inverses, algebraically, we can verify something is an inverse, where if I take the composite, f of g of x or g of f of x, I'm going to get x, right? So that's not a coincidence. So for inverses, when you substitute one function into the other, you're going to always get x. And then if I have the point, for example, -4, 1, if I flip the point, it's going to be on the other function. So again, like if I was to take, let's say I had the point 2, 4, it's not a coincidence that on g of x, 4, 2 is on the other line, right? They're just flipped of each other. All right, so the big definition we're going to see, and this is going to be kind of the theme for the whole rest of the mod, is talking about inverse functions. So when we look at this inverse function definition, what it's saying is that g of x is an inverse of f of x in our example we just saw. And so an inverse function is a function that reverses the operation of a function. So if I was to take, like we just saw, f of g of x, I get x. Instead of calling it like g of x, we're going to see this idea with like a little -1. So the f inverse. So the inverse function is noted with that little -1 on top. So instead of having to make a brand new function, we just put a little -1, and that's the way of talking about the inverse of a function. So for this second example here, it says find the inverse of each linear function. Verify the inverse by evaluating. And you're not going to have to verify every time. This is just for the one example. So the first step we're going to do with this is I usually like to tell students, let's rewrite this just for now with a y, just so it's easier when we kind of do our next steps. All right, so the first thing I did is I rewrote it. Instead of writing it with f of x, I wrote it with a y. Just so there's less, I don't have to deal with an f and an x in the same problem. To find the inverse, really all we're going to do is now I'm going to rewrite it a second time, but I'm going to change the places of y and x. So I'm going to rewrite this now as x equals 3y plus 4. And the reason is that's going to help me find the inverse operations for that function by just simply solving an equation we're used to solving. So once I flipped this around, I'm now going to go ahead and solve for y. So to solve for y, I'm first going to subtract 4. We get here, if I was to put this together, x minus 4 aren't like terms, so I'm going to rewrite that over here. I have 3y. I'm now going to divide every term by 3. And so I have x minus 3 minus 4/3 equals y. And this is actually going to be my inverse, right? But I'm going to rewrite it so it's easier, or it actually answers the question, right? So I'm going to now rewrite it as the inverse, and then I'm just going to rewrite what I just found. And so this is the inverse function of that function I started with. So this function undoes all the operations of the other function. If I wanted to verify it, and again, you're not going to have to verify it every time, but just to kind of show you algebraically what happens, if I was to verify it, I would do the same thing as before. I rewrite it as 3x plus 4. I would put an x over 3 minus 4/3. Distribute. The 3's cancel out, so I have x minus 4 plus 4. And then I would get x. So that actually verified that this was the inverse. So yes, it's an inverse. But our actual final answer is going to be this function that we just found right here. In example 3, we're going to still find the inverse, but these ones, instead of being linear equations, they're going to have either a quadratic involved, or we're going to solve with square roots, or we're going to have a radical involved. So the steps are going to look exactly the same, and again, you can kind of shorten the steps a little bit if you like. So the first thing I'm going to do is rewrite this with y instead of an x, or instead of an f of x. And then we're going to rewrite it where we swap the x and the y, because algebraically it makes it a little easier for us to solve. So I have here y plus 2 squared minus 7. And now we're going to go ahead and solve for y. So we're going to get y all by itself. You're going to use the square root method like you used in Math 2. So we're going to add 7 to both sides. And I actually don't need this little parenthesis right here, probably. Okay. And then we're going to go ahead and square root. Okay. So when we square root it, we get x plus 7 equals y plus 2. And then I'm going to subtract 2 from both sides. Technically, you can do a plus or minus with that x plus 7. And we're going to talk more about that in one of the later sections. But we would take this as your answer too. All right. And then finally, the last example here, part B, we would do the same thing. So this one I already have as a y, so we can just kind of flip the order. And then just solve. If we have a square root, we're going to go ahead and square both sides, because again, the inverse of square rooting is squaring and vice versa. This we get x plus 5 quantity squared equals y plus 4, and then we would just subtract. So if I was going to rewrite this, for this first answer, we probably would want to write our little inverse. For that one, and then for this one right as well. All right, for example 4, there's actually multiple ways to do the same problem. I'm going to show it just by finding the inverse first, just to get a little more practice with it. But this is just one of like a whole bunch of different ways you can get the answer. So the first thing, if I wanted to write the inverse for this problem, again, I can flip it around and solve. I have a 1/3 y. I can multiply both sides by 3. And then if I simplify, this would be my inverse function. And then if I wanted to find the inverse of the number 1, I would just put 1 in, and that would be my final answer. So the inverse of 1 is 1. For the second one, I can do the same thing, right? I can find the inverse first if I want to, or I could even use the 5 and solve it a different way. I'll just solve it just so you can kind of see another example of it being solved. But again, multiple ways that you can do the problem. So we're going to square. Add 4 to both sides. And then this would be our inverse. And so now when we evaluate, you're going to put a 5 in for x. And we would get 21. If you have any questions, you can sign up for T-Bolt time, get help from the center, or ask for help during class.